Are you confused about whether to use NumPy or Pandas for your next data project? You are not alone. And using the wrong one can slow down your workflow or even lead to incorrect analysis. But what if you could finally understand the difference and know exactly when to use each? So in this video, we are clearing up the confusion once and for all. First, we'll dive into NumPy, your go-to library for fast, efficient numerical operations. You'll learn how to flip arrays, stack them, and even generate random numbers, all explained in simple and visual way. Then we will switch over to Pandas, the powerhouse for handling structured data. From importing CSVs to cleaning missing values and running quick statistical summaries, you will learn how Pandas can completely transform your data analysis workflow. And also, if you are serious about growing in data science and AI field, make sure you join our free live masterclass on AI and machine learning. You'll get hands-on experience with real-world datasets guided by industry experts. Thousands of them have already benefited from our program and landed their dream jobs. So register through the link given in the description below.
So we did look into null values, right? After that, there is one more section that I want to cover, which is about encoding. See, we will see encoding in the session of machine learning, okay, in more depth. But since it is a technique that is being utilized, making use of pandas to an extent, so we need to understand what is encoding. So if you remember, when we were discussing about machine learning, so I hope you remember in machine learning, okay, we do have something called as inputs. Okay, we also call input as features. Okay, or we also call input as independent variable, right? And then we have also got something called as output. Okay, output will always be one thing, but we do have something called as output. We also call output as target. Okay, and we also call it as dependent variable. Okay, so we have these two things. Now my point is output can be of what type? Like if I ask you with respect to variable type, so what is output type? What are the two types that we can have? So we have category and we have continuous, right? Now, the next point that we need to understand is this is going to decide which algorithm are you going to use. This is going to decide which algorithm are you going to use, right? Okay, whether it will be supervised, unsupervised, that is different. Whether it will be regression, whether it will be classification. Okay, and if it is not there, if the target is not there, if we say no target, then we can call it as self classification, which is clustering. Now, the point is we also have something called as input features, right? So when we say input features, again, input feature can also be category type. Like we can have whether the income is high or low. Okay, based on that, the target might be whether we want to approve the loan or not. So this can also be category and this can also be continuous variable, right? It's not like it is continuous or category is only the property of output. Absolutely, output is also a number or a category, but that doesn't mean input is not a number or category. Okay. Now, my point is whatever input we have in category, whatever input, whether we have input in category here or we have input in category here, machine learning does not understand anything called as category. Like it does not understand category. Whether you write category as yes or no, okay, or whether you define category by 0 or 1. If it is a category, okay, if it is a category, then we need to, whether you represent it by 0 or 1, whether you represent it by y or n. If it is 0 and 1, we can say that it is a number, but we need to understand that. We will understand, okay? But right now, the point is when we have category in whatever might be the thing, yes, no, or you can have lower income, higher income, whatever might be the thing, okay? So if the category is non-numeric, okay, which is going to be the case, right? So we need to convert the category into number type. Okay, what is the thing? We need to convert category into number type because machine learning, as a process in machine learning, they do not understand anything which is text. I hope that makes sense. Now the point is there are two ways. So there are more than one, but let me just put it simple. We want to convert the category. I told there are categories, right? So we need to convert. Our aim is the category should be converted, okay, to number type. Okay, I'll use this layman term number type, but that's okay. So the aim is category should be converted to number type so that machine learning algorithms can use that. Okay. And once they use that, we will be able to go ahead and build a machine learning model. Okay. So for that, there are two types. One is label encoding. One of the type is label encoding. I'll tell you the type. One of the type is label encoding. Okay. And another type is fun hot encoding. I'll tell you what is the difference. This is also called as dummy variable. Okay. We need to understand this. Okay. So do remember, one of the type is label encoding, another type is one hot encoding. Okay. That's it. Okay. So now what do we need to do? Any table we have. Okay. So the first thing that you can see, if I ask you loan ID, okay, wherever we have a string, that is category, gender category, applicant income number, co-applicant income number, loan amount number, area category, right? And loan status is also category. Okay. It does not matter whether it is on the input side or output side. Whatever we have as category, we need to convert them into what? We need to convert them into numbers. Okay. Now the point is when we check the data type by making use of Python's method, Pandas method, which is dot D type. Okay. With the variable, when we check, we found that by general sense, you will find that all categories will be shown as objects. Okay. You will see that because it has been loaded in a Pandas data frame. Okay, so all category will be loaded as objects. So the first thing that you need to do, you need to select all those columns. So what I have done is, if I can show you, I need to select all columns, whatever columns we have, right? We need to select, we need to say DT calls. Okay, and we need to go ahead and use a method and say that please convert them into category. Now, what I have done, I have defined this list. Okay, if I scroll up here, okay, can you see I have defined something here called as calls. Just see. Can you see calls? So what is this calls containing? This is containing a list of all categorical calls. Is it okay? Now, what are we going to do? The basic process is what do you need to do? Since this are representing, so I have already created a list. So wherever there is a category which will be represented as object in Pandas data frame by default, you need to select all those columns. So you need to create a list of these columns. And then you need to say as type, and you just need to say category. So what are we saying? DT of calls. That means in this DT variable, there is a list of column that I'm interested, and I'm saying do a transformation on this DT of columns and convert them into category. Okay, that is the thing that we are looking for. Now, suppose if you want to see all, you can see dt.dtypes. Okay, I was only seeing DT calls, right? Now, if I see dt.dtypes, you can see what has happened. I'm not interested in loan ID, because I want to drop loan ID. I hope you're getting, because I do not want to convert loan ID into category. I hope you're getting, because loan ID, if I see loan ID, everyone will have that unique ID, right? I hope that makes sense, right? So it's better to go ahead and drop. Okay. Every loan ID will be a category, which will make too much of problems, right? This is called as a data which is of no use because this is noise data. Okay. I hope you're getting. Now, if I show you, so we can drop it right now. I'm not interested. If you want to drop, you can just use drop any and we can pass this. Okay, column information. Now the point is just see what are we trying to do. This is where we are applying one label encoder. To apply label encoder, you just need to say whatever columns you are interested. So I'm saying for columns, this is I. Okay, for I means for iteration in columns, COLS. Okay, what I'm saying, DT of columns. Okay, I'm just going to pass DT of columns and then I'm going to say DT of columns. Now this is I. If you want, I can change. Don't get confused. Okay, this is I. Okay, so this is a list. Guys, this is a list. So we are saying for all the elements in this list, all I, element number one, element number two, element number three should get converted into categorical codes. That's it. Okay. Now, if I run this, okay, can you see int 8? Okay. So again, I'll repeat. This is just an iteration. What are the three columns? For gender in this list, data type of gender should be converted to category code. Okay, cat.code is going to go ahead and do label encoding. This is label encoding. Do remember this. Okay, and we will understand this much more clearer. Okay, because this is already clear, but we will be required to go ahead and use all this stuff. Okay, so now this is done and this is done. Okay, sorry, I made an error or what? What did I do? Okay, this is already converted, it is saying. Actually, it is already converted. That's the problem. Okay, can you see? Because I've already converted, right? So now it is saying I
Yeah.
can't use it. It can only be used with category type. I'm rerunning it, right? That's the problem. Sorry. Is it okay? What is label encoding? Label encoding is converting your label into a encoding thing. Encoding means number. Simple. Converting your label into number. Now the problem is if I run this dt.head, see what are we getting. So the point is, now I'll tell you. What are we getting? 1, 1, 1 for whatever might be the case. You can check what was the case. If I show you the data, male. Okay, so wherever we have male, we will have 1 because we have already dropped null values. Okay, so wherever we have male, we will have 1. Wherever we have female, we will have 0. That is what we are able to get. So we need to drop null or we need to replace it by mean, median, mode. If you remember, we need to do that. So we have already done that. Okay. One more important thing, before you apply, you need to eliminate all the null values. Then only you apply. Is it okay? All good? So I have already done that. Now, if there are 3 types, you will see 0, 1, 2. If I show you all the DT only, okay. If I run DT, you will see 0, 1, 2. There were 3 areas: rural, urban, semi-urban, I guess. Okay. So wherever you will have 3, you will find 0, 1, 2. Okay. This is how it functions. Now this is done. Now, very important thing for you to understand. Okay. Now try to understand what I'm saying. Now, if I say, think about it. Okay. I'll say temperature. Okay. There are 2 category of temperature, low, high. I'm just saying it this way. Okay. Now, if I say temperature, so low. Okay, now if I'm going to say low is then less than high, everyone agrees. Similarly, we can even say high is greater than low. Now, suppose low was being introduced by 0 and 1 was being introduced by 1. So you can say that 0 is less than 1. Absolutely sense. Okay, on this type of category, if you apply, that makes absolutely sense. I'll tell you why, because this is integer. Try to understand. These are integers. Now, if I say gender, okay, what did I say? Gender. Now, if I say male is greater than female, do you think male is greater than female or female is greater than male? Makes any sense? No, right? Similarly, rural is greater than urban, urban is greater than semi-urban, nothing. Yes is greater than no. We cannot say that, right? Right? So the point is, whatever we have done, to be very frank, we have just understood. But the problem is, since this is int, what is this int? We should avoid using this int for any column which is non-ordered. This is ordered, right? So we can use it here. Okay, low is greater than high was orderly correct also. Okay, so in that kind of scenario, if you use label encoder, that's well good enough. Okay, but again, I'll repeat, if you use it, okay, if you use it for gender, area, loan status, okay, it is not preferred because what happens in the machine learning, I'll remove this, in the machine learning, at the time of training, all this will take part, right? All this will take part at the time of model training. And you do not want this to be considered as integer because this is not integer. This is a category which is being considered as integer. Okay. Is it okay? So label encoder should be preferred when we have category which does indicate mathematical interpretation also. Now, the next thing that I want you to understand is, see, I'll tell you, regression algorithms. Again, listen to me very carefully. Regression algorithms, okay, are okay. Again, I'll repeat, are okay even if you give category a number value. Again, I'll tell you, regression algorithms are okay even if you give number values. Like even if you use label encoder with regression, that's okay. Regression algorithm. That means whenever we are trying, again, I'll repeat. Here you're trying to predict loan status. You can even predict how much loan amount, right? Or what is the salary, just to give an example, right? Something you want to approve, find which is continuous. So suppose you were trying to find what will be the price of the house. Just give an example. The price of the house is continuous, so you are going to use regression algorithm to build the model. So at the time of regression algorithm, if your, so it's understood that if it is regression algorithm, target will be continuous, right? So the point is, whatever we have here, okay, even if you use label encoder, regression algorithms are okay. They are okay with it. Okay, because regression algorithm is all about, we will see that it is all about numbers. I hope that makes sense what I'm saying. In classification, okay, in classification, some algorithms are okay, like decision, there is something called as logistic regression. Okay, they are okay. Okay, but apart from that, it is not recommended. If you're using logistic regression, you can use label encoder. If you want to map high or low to anyone, you can go ahead and map, but they are okay. Okay. Regression algorithms are okay with label encoder. Logistic regression within classifications are also okay with numbers. Okay. If you assign numbers. Okay. But that doesn't mean you cannot assign dummy. Okay. Dummy means one hot encoding. Now, one more important thing that we need to understand. Suppose there is city. Okay. There are three city choices. Delhi, okay, Mumbai, and let me say London. Okay, now my point is, suppose it went ahead and gave it a value of 2, 1, and 0. Okay, now according to mathematics, what do we understand? Just think about it, or I'll just put it in simple terms rather than this. Let me just take it as 1. I'll just put it as 1, 2, 3. Okay. Now let me ask you, 1 plus 2 is equal to 3. Is it correct or not? Correct. So does that mean that Delhi plus Mumbai is equal to London? We cannot say that, right? Again, what I mean to explain you is greater than implications are also there. Addition, subtraction implications are also there when we use label encoder. But again, when you use logistic regression or when you use logistic regression from classification, or when you use linear regression. Okay, these two are different. Linear regression is for predicting continuous variable. Logistic regression in the classifier is used to predict the class. Do remember, logistic regression is different. Linear regression is for regression. Logistic regression is for classifier, though it is derived from linear regression only. Okay, but this is used for classification. Linear regression and logistic regression are okay even if you use label encoder. Okay, now we'll go ahead with one hot encoding. This is the same concept that was predominant till the NLP, like initial, what you can say, advent of NLP everywhere, one hot encoding was used. Okay, and that same concept we are also going to go ahead and use here. Now let me take you ahead. What is one hot encoder? I'll tell you how does one hot encoder work. So what one hot encoder does, suppose there is a category of colors, red, green, and blue. Now we cannot say red is greater than green or green is greater than blue or any other thing, right? So what does this do? This tries to solve the issue of label encoder by going ahead and creating three different columns for red, green, and blue. Now just to keep it simple, if I put red color, okay, red, green, blue, three categories, right? Suppose marks student subject, choice of student subject, English. They can take any one subject. They can take English, they can take math, or they can take science. Okay. Now, rather than this having one column wherein we have this, we will represent it separately: English, math, and science. Now, wherever the person has taken English, we will say 1. Wherever it has not taken, we will say what? 0. Is it okay? So there was one, this is student, suppose this student loves, sorry, this student loves red color. This is student number 1. So this student loves red color. So automatically he has only one choice. So he will take this. This loves green color. This loves blue color. This also loves green color. So it's not like there cannot be two, one. Okay. This person also loves red color. So this is student 1 and it goes up to student 6 or 5. Is it okay? So when we do this, what is basically happening? We are going ahead and creating multiple columns. Okay. Now let us come to the main thing. Now think about it. Suppose you have 16 loan IDs. Now think about it. How many loan IDs? First of all, this is a noisy column still. If there are 16 loan IDs, how many columns will get created now? 16. Now think about it. If you create 16 columns extra, don't you think you are creating imputations more and more without any like logic, right? Is it making sense? First thing, this is noisy. This is not going to help you in machine learning prediction. Second, this is not required also, right? Okay, guys. That is one thing. That's the reason. What are we doing here? We are dropping the loan column. We could have dropped earlier also, So we are creating one more data set, which is df2. We are saying you can drop as many data sets if you want to create, you can create. So I'm just dropping it. Now, if I see the head, now I can see that this is what I have. Okay. Now the point is whatever we have. So to be very frank, we again need to remove this. I have not removed. You can check this and we can drop also. Drop any. Okay. Right now I have not removed. Okay. Now what I'm going to do to remove, to get this one hot encoding, I told you this is also called as dummy variable. Again, to apply dummy variable or to apply one hot encoding, please do remove this. Okay, please do remove this. Okay. Now, if you see, if I do not remove, it will keep nan only. Okay. Is it fine? If there is nothing, it will not do anything in there itself. I hope that makes sense. Now, what I'm going to go ahead and help you understand is first we need to remove, or we need to do that mean, median, mode, whatever we want to do. Right now, I have not done that. But if you want to do one hot encoding, you will use get dummies and then you will call directly, you will call df2 directly. It does not require you to call it separately. If you remember, if we go up here also, we were directly calling dt. Okay, we are saying for I in calls, okay, we were going ahead and saying do get it. No, not directly calling. We were only calling that list which has the category. So here we only call category. Okay. In the dummy variable, the best part is in the dummy variable, you just need to call the whole data set. Okay, you just need to call the whole data set. If you remember df2, we are saying pd in the pandas data frame, there is get dummies function. Apply this on data2. The moment you apply, you will see wherever there is category. Where was the category? Female and male. Okay, is it fine? So gender female, gender male, it created. Rural, semi-urban, urban, low in status, yes, low in status, no. If it would have been regression, this would not have even come into existence, right? Because this would have been a continuous variable. Is it okay now what I'm saying? 0, 1. This is what I'm saying, 0, 1. Okay? You call it 0, 1, you call it true, false, doesn't really matter. So what has happened? You took that one hot encoder method, which is get dummies. You applied it on the overall data set. Now tell me, applicant income is a number or a category? So nothing will happen. Co-applicant number, nothing will happen. Known amount, nothing will happen. Wherever you have category, that will automatically create two columns. If there are three, it will create three. If there are two, it will create two. If there are 16, it will create 16. Okay, automatically it does. And it gives the value as a category only. Okay, 0 and 1. So now my point is, now tell me if you remember, logistic regression uses what? Regression is by name, it is going to predict the continuous variable, right? So in the regression, can we now, for regression, if you remember what was the algorithm that I told? Linear regression. Now think about it. In the linear regression, wherein everything will be based on number, can we pass this? So we cannot even pass this. That's the first thing. Okay. Similarly, in the logistic regression also, think about it. In the logistic regression also, we cannot pass this. Try to understand what I'm saying. We cannot pass this. Okay. Now we'll go vice versa. Okay. If it would have been 0 or and 1, think about it. Considering the old case. Okay. So if I go up, we cannot pass this, right? But if we go here, this case, now what did I say? In the classification, okay, in the classification, can we pass this 1 and 0? We can pass this if it is of the type logistic regression. Okay. We can even pass it for others also, but it will not have that same significance because it is an integer. Okay. There is also one more way. If it is an integer, you can create it as unreserved integer, UINT. There is a method, you can just check it over GPT also, that you can convert your integer into UINT, unreserved integer. That means though it is an integer, but it does not take part in the mathematical interpretation. Okay, when you use any type of logistic regression or linear regression type, which expects everything, okay, to be in number. Okay, that's okay. But if you use anything else, that can be a problem. So again, I'll repeat, I'll keep it simple. Here you can see linear regression, logistic regression, neural network, support vector machine, k nearest neighbor, decision tree, random forest, light GBM. This can effectively handle one hot encoded data. They can handle one hot encoded, but that doesn't mean we should use it. But if you want to use, you can use it. Again, similarly, if I go up here, okay, I think I should have mentioned somewhere. Yeah, Can you see decision tree classifier, decision tree regressor can handle this. Random forest can handle. I've written everything, but I've also told you what will be the pros and cons. Okay, what is preferred? If you have something which is ordered, so again, I'll repeat. I'll just keep it simple. If you have something which is ordered, okay, then you can go 1-0. Okay, that's fine. But if there is something which is non-ordered, then what would you prefer? Dummy, right? Now, I'll give you one more thing. Now, think about it. I'll just take you through one example. I'll just take you through one example. So let us just focus on this aspect. Okay. Now, my point is, if I know this person is not living in rural, this person is not living in semi. So where is this person living? Tell me. Urban, right? Now I'll hide this. Suppose this is not there. And I want you to predict urban. Think about it. What I'm saying, I'll hide this and or I'll do one thing. I'll hide this. Okay. Let me hide this. Think there is nothing as such. Okay. And I want you to predict rural. Now tell me if you have seen two, if you know that this is false, this is true. So tell me what will be the value of rural for this. Now, similarly, if this is false, so this will be false. If this is false, this is false, this will be true. So now the problem is, I'll just give it a very simple example. Why do we need to drop? There is something called as drop at least one dummy. Now the problem is, I'll just give an example. This is called as perfect mapping. 100. Suppose you have got this kind of a thing, whatever you have got. Okay. This is called perfect mapping. Okay. When I say perfect mapping, just to keep it simple, when the machine learning model sees other things, other features, okay, and when machine learning model sees this kind of a feature, okay, wherein the mapping is so perfect, it will have inclination to go ahead and give more importance to this. Just to keep it simple, if you have a scholar sitting in front of you in the exam, okay, who is showing his all paper to you, okay, and you can see the answer very correctly. Or suppose even if there is a duffer who is sitting in front of you in the exam, okay, and if he's showing everything perfectly, like keeping the paper on the right side, even if you know the answer, you will be more inclined to see what is he writing, right? I hope that makes sense. So this is called as a case of perfect mapping. You will directly map, like just think about it. If someone is hiding the paper and writing it, or if someone is showing everything so clear that you will automatically be more inclined to see what is this person writing, right? Similar to that, if you show numbers to machine learning model, and if you show the numbers in perfect pair, this is where the machine learning can go ahead and do bias, okay? Because it will have a habit of giving more importance to this theory category rather than giving equal importance to all. So how can you eliminate? One way to eliminate is at least remove one, right? So now think about it. Male and female, if you remove one, still you can predict. Now, the point is, even if you remove female, see, machine learning model is not interested. I'll tell you. That doesn't mean it will not be able to give answer for a gender who is going to be a female. Think what I'm saying. If female data you are going to provide, automatically it will consider it as what? Opposite of male, right or not? Yeah. So once you eliminate one column, that doesn't mean the importance of that column is lost. Okay. That information is all there in the pre-processing. The pre-processing system knows what has been dropped. Okay. So when the person will come for a loan, and if he's going to be a female, that doesn't mean that the system does not know that this person is not even allowed. No, no, no. The data will be allowed. In the pre-processing, it is already embedded. Okay. That for female, this is what the value will be. I hope that makes sense what I'm saying. Again, I'll repeat. Any column can have anything. That doesn't really matter. It can take female first, male first, doesn't really matter a lot. The most important thing, what I'm trying to help you understand is even if you drop, the machine learning model under the pre-processing step knows everything. When you will see the machine learning model build, you will understand that machine learn when you're going to ask the machine learning model to give the response during the project time, you will see that it also requests you to pass the pre-processing along with the model. Okay, so it once the model data comes, it looks into what is there in the pre-processing that might be left in the model. I hope that makes sense. Now my point is, think about, suppose I'll just put it simple. I had a category of income. Okay, I got a data from different people. Okay, and I got different people have different ways of categorizing. Okay, just to keep it simple, someone will say low. Okay, then someone came ahead and told medium. Someone said super low. Okay. Someone went ahead and said high. You can say high. Okay. Someone said royal. Okay. Someone said extremely royal. Okay. These are the categories. Now, how many categories do I have now? Can you see? 1, 2, 3, 4, 5, 6. Now, if there are 6 category, even if you drop one, think about it. Even if I drop low, you will still be able to know if 5 are there automatically, you will know what is the next one, right? Is it okay? If 5 are false, this will automatically be true. If any one of this is true, then automatically this will be false. Okay? Is it okay? Now, the point that I'm trying to highlight is now try to understand even 5 is a lot of category depending upon the size of the data. So, what do you try to do? First, you drop for. Apart from that, you also try to go ahead and check. You will go ahead and check the variance in the data. Okay. Or you can say you will go ahead and check how many people are there between what is the variance. Okay. For the people. Okay. For different values who are having low and super low. Okay. So if you find variance, okay, for people who are between low and super low, you can consider them to be one category. You can consider these three to be one category. Is it okay? You will check the data, okay, and you can consider this also to be one category. So how many categories are there now? Three. Three minus will be how many? Two. So what you're trying to eliminate, you are trying to eliminate the what do you say? The perfect picture. If you remember, I told the perfect picture where you see either one or either zero. Okay. You try to eliminate as much as possible. Okay. Why do you go ahead and do? Because you want the model to see less number of category. The more the number of feature, it's okay. But the more the number of feature, that means the more the output can get prone to what you can say a non-correctness. So that is where we need to go ahead and check that. What did I say? Tell me. High, royal, and what did I say? Extremely royal. Suppose I replaced all this by a new name, rich. Okay. Now, suppose you have already trained the model. Now you came with this is the model that is trained, which is only seeing a category called as what? Rich. As a user, as a user, I may allow you to go ahead and pass what? Rich directly, or I may allow you to pass high, royal, or extremely royal. Okay. So when you pass high, royal, or extremely royal. Before going here, there is also a pre-processing thing attached to it. So what happens? It automatically pre-processes them into what? Tell me. It automatically pre-processes them and keeps this data. Okay, these three variables are accepted. How will it know? Because in the pre-processing, you have already stored all these values. Okay, simple. So if you have stored it, automatically understand these three variable inputs are accepted. And these three variable inputs are mapped to what? Which? Either you map it directly or you take it through preprocessor and then pass it here. Okay. Now, this is what I was saying, dummy variable trap. Dummy variable trap is dummy variable trap occurs when you create too many dummy variables leading to multi-collinearity. Multi-collinearity means a perfect picture you show. Okay, a perfect picture you show. Okay, this happens when the dummy variables are perfectly correlated. I told either 1 or 0, which causing issues in regression. For example, if you have a category red, green, blue, creating 3 dummy variable will result in perfect multi-collinearity because the sum of this will always be 1, leading to overfitting. You can look into this in more detail. So how to avoid? You should always do k minus 1. And what did I say? If you have two values still, you can go ahead and do that. So first I dropped. I'm creating one more data set, dropping the loan ID, and then I'm saying this is where you do avoid multiple linearity. So if I run this, you will see the head as C. What are we getting? Gender male. So where is the female? Tell me. If this is false, female is equal to what? True. If
True.
this is true, female is equal to false. Okay. Similarly, we have only semi and urban, and we have full. Okay. So what do? You just say drop first is equal to true. When you say drop first is equal to true, it will go ahead and drop the first one. First, and first. Can you see no male and no female and rural got dropped here. Okay. If I show you the data type for this, okay, I'll just show you, you will automatically understand. Just look into this. Okay. DF3, this is done. Now let me just take one thing ahead. I think this I have already run. Now let me just add something and you will understand. So yeah, if I show you the data type for this df3.d types, this is important. Okay, let me run. What do you see? Boolean. That is what I'm trying to help you understand. This is not integer. Okay, simple. This is not integer. Even if you map false is equal to 0, this will still be Boolean for us because we are considering 0 to be Boolean. What I'm trying to help you understand is if this is Boolean, see what I'm saying? If this is Boolean or even if it is 0, but it is Boolean, okay? Is it fine what I'm saying? Now tell me if it is Boolean, is 0 greater than 1? No. Yeah, so it is changing to two columns, right? Why is it changing to two columns? Because in one column, you will have either 1 or 0, right? 0 means this person is not a male. And 1 means what? It is a male. Simple. True or false, right? If I have false here, see, if I have false here, what will be the answer for female? Tell me. True. I am telling you why do we do this? Because we want to avoid the usage of integer in our machine learning algorithm. If you use integer into machine learning algorithm, it will take part into calculations, right? Okay, especially for linear regression, logistic regression. Okay, decision tree does not expect you to make use of, or I'll say classification does not expect you to give category as 0 and 1. Okay, or number integers. Okay, category should be Boolean, but when the category is Boolean, the point is if you have it all the things together like male, female, okay, everything you can have it, right? But what did I say? It's your wish. If you want to have male, female, low, medium, high, you can have it. Okay. But the problem earlier was it was an object. So if you want to have it, the point is once you have it as dummy variable, then this can take part in your machine learning as a Boolean variable. Okay. Is it fine? And you need not require to be worrying about this now. This was important. Now, why I'm showing, because this will help you in the sessions also. Now, data normalization. Now, what is data normalization? Data normalization will only apply where? Think about it. Will it apply to numbers or will it apply to category? Numbers, right? That's again, think about that same issue. Okay, so when you're going to apply, you will only select which columns, which are category. Again, similar to label encoding. Remember label encoding? That was very important concept. Okay, dummy was okay. It was important, but label encoding is where you need to work out. Okay, so similarly, when you want to do normalization, basically that means I'll tell you normalization. Okay, again, I'll repeat. Suppose I want to predict y. Y is the salary of a person. It depends upon number of hours, okay, worked, okay. I'm just giving an example, okay, plus family savings. Okay, I'm just giving an example. Salary will be depending upon number of hours worked. Just give an example, okay. Suppose 8 number of hours worked, or suppose in a month I'm saying, okay, monthly salary if I'm saying. So suppose 8 into I can say 176. Okay, plus family saving is equal to suppose, okay, yeah, 1 million USD. Sorry, 1 lakh USD. Okay, now the point is, now tell me, are both the numbers contributing equal to the prediction of Y? Which number will dominate? 1 lakh or 176? Which number will dominate, guys? Do not worry about the units right now, but we do know that these two numbers, if you I just put it in the raw form as numbers, you will automatically understand, okay, 1 lakh will dominate over 176 hours, right? That is one thing. So the point is you want to bring both this variable. See, if you this dominate, effect of this will be less and effect of this will be high. So that means if someone has high family saving, automatically he will get more salary. Just give an example. Okay. So this kind of things will not work out. So what do? You go ahead and perform data normalization on all numerical columns, not on category. Why do you do? Because you want to scale numerical data to a standard range. Okay. Between 0 to 1. Okay. You can go ahead and do that. Okay. So there are two types. there is something called as, I do not remember, but I'll just help you out. Okay, there are two types also in this, but just to keep it simple, we can standardize it between any now two value, but right now we can standardize it between 0 to 1. So the data to scale, I am creating one list. Can you see? I am doing iLock, and by luck, everything was together. Can you see? Co-applicant income, loan amount. So what did I say? This is column number. If you remember, I'm taking it from the data set that is cleaned. Okay. So I'm saying column number 2 to 4. I say 2 to 5, right? So all rows, and here I am saying column number 2 to 5. So 2, 3, 4, because this is, I also have something. If I show you data set clean, I have the loan ID also in that. Okay. So that's the reason whatever you have, you can select. So now if I show you, I'm just using it. And now I'm going to say, this is my head. This is the thing. Now what I'm going to do, there are scalar. Okay. There is standard scalar. What do you need to do? In the sklearn, we will look into this, guys, once we go ahead with the session. In the sklearn, there is a module. There are different sub modules in sklearn. One of the module is pre-processing. Okay, so in the sklearn, we go through pre-processing and we import something called as standard scalar. Okay, standard scalar converts all the category between 0 to 1. Okay, that's the thing it is going to go ahead and do. So whenever you have a class, you need to create an instance of a class, an object of a class. Whenever you have a class, if you have a function, then you can directly call the function with a method type. But when you have a class, always remember you create an instance, and in that class, you will have a method. What is the method? Fit underscore transform. So with the help of this variable, you can call fit underscore transform and directly pass the data that you have created separately. So once you go ahead and do, I'll run this, I'll run this, and I'll run this. Now, if I print it, you can see this is what I was saying. Okay, so right now, sorry, there are two types. I'm using standard scalar. I'll tell you what is the purpose of standard scalar. Standard scalar, if I tell you, so there are two types. In min-max, all the value will always be between 0 to 1. Standard deviation can be anything. Okay, it can be any value, any value. Okay, when we use min-max. And when we use standard scalar method, okay, again I'll repeat. When we use min-max, the value will always be between 0 to 1, and the standard deviation can be any number, any number. When we use standard scalar, the value will be between minus 2 plus, the value will range from minus 2 plus. Okay, it can also be plus 2 plus, but generally the highest value will be plus and the minimum value will be minus. Standard deviation of this will always be equal to 1. Okay, this is one of the things that we need to understand. So you can use any case, that's okay. So right now I'm using standard deviation because you can see some values are minus, some value are plus. If you want to check, okay, I'll just show you. We had this. 1 second. I'll just show it to you. It was writing something. Simple. So you have this, you can call and you can normalize. That's it. Okay. So what are we doing here? We are going ahead and making use of the scalar fit transform. Can you see? And we can get this thing. If you want, we can just check it out. I'll copy this. Okay. I'll show you the output. So this is done. Okay. This is okay. I'll also show you what is the thing. But before that, let me just put it here. Okay, I'm just doing some calculation. Before that, let me just put it. Type 2 also I might have done. Yeah, I have done it. Can you see? So we can use min-max scale, or we can even go ahead and call min-max scalar class, or there is a function min-max scale. So here, if I show you, I'll show you the other steps. Okay, so now I am saying data to scale. And here you will see the value between 0 to 1. Can you see? Value will always be between 0 to 1. Okay. Is it okay, guys, what I'm saying? It will never change from that. Okay. Now, the one of the thing that I'm changing is I'm getting it as an array, right? So when I'm getting it as an array, I want to see which column where, right? So I'm just doing something. I'll just show you. I'm saying convert NumPy array into Pandas data frame. So if you get an array, we are going to look into NumPy. So whenever we have array, that means this is a NumPy thing. NumPy always goes ahead and stores the value in Pandas in the form of array. So I have this. So now what I'm going to go ahead and do, first I'll load the Pandas data frame. If you remember, Okay, so first I load the pandas data frame and then I'll go ahead and show you the head. So what I'm getting, if I show you, I'm just loading this as a scalar with pandas data frame, and then I'm seeing the head values of this. That's it. I'm printing the head value. Now the point is here, you can see I'm getting 0, 1, 2. But actually, column name has changed to 0, 1, 2, but actual name was what? Applicant, co-applicant income, and loan amount. So what I'm saying, I'm just trying to map. I'm creating this, and then I'm saying use as a scalar. Column should be changed to column names and then printed. Okay, that's the only thing I'm going ahead and saying. So the point is I'm saying DFSS is having this column name 0, 1, 2. Please change it to this 3 column names and then print the DF head with the values. Okay, sorry, not DF head. What do we need to print? This. Okay, can you see this now? I hope you're getting what I'm doing, guys. Okay, so we can use any. If you want, we can check it out when to use min-max, when to use scalar. Okay, in short, ingestion. Okay, sensitive to the scale of data. Okay, and standardization when you want to have a data centered around mean with a standard deviation of 1. Okay, whenever standard deviation is equal to 1, always remember mean will be equal to 0. Standard deviation is basically like this bell kind of a curve. Okay, so you can have this also, and you can see all those algorithms also. Fine. Now I'll just go ahead. So we have already looked into this same thing. I'm doing it here also. I'm just mapping the column name so that I get the things correctly. Now, what we have understood in pandas, we have understood a lot of things. Now we'll look into one more thing, data splitting. Now, what is data splitting? Now I'll tell you why data splitting is important. So you have a data set, right? You have a data set. What do? You split the data wherever you want to split randomly. So what we basically do, we do a 80-20 split. Okay. If the data set is huge, if the data set is suppose only 100 values, then you can go ahead and do a 70-30 split also. Okay, so general recommendation is 80-20, but if you want, you can go 70-30 also. Why do we require data splitting? Because first we are going to train the model. At the time of training, if you remember, I told you we are going to show the label. Okay, at the time of testing, what are we going to do? We are going to hide this label. This will be hidden, right? This will be hidden, right? So what are we going to do? We are going to show this. We are going to get the prediction. Whatever prediction we get, we are going to compare it against what we hided, and then we will check the evaluation. How accurate is it? So we will look for evaluation metrics. Okay, that is where what we go ahead and do. So for that, we need to split the data. Splitting the data is a technique in machine learning to divide the data set into separate parts for training and evaluating. Okay, this helps the model to generalize. Before going to see the unseen data in the real world, it's important that you go ahead and take more of a prelim. Okay, so used to train the model, training. There is also something called as validation. Okay, what is validation? I'll tell you. See, again, this perception keeps on changing. So whatever you have trained, okay, I'll just put it simple. Suppose this is trained data wherein you showed both the things. In the validation, you use the training data. Again, this thing can change. Okay, in the validation, you use the training data on which you have trained, and you hide the label. What do? You hide the label. So the model, okay, on which the data was trained, at least it should be able to respond good here itself, right? So in the validation, you can validate the model, okay, against the data that has been hidden. Apart from that, there is one more terminology of validation. Validation basically means, see, you have a data set. Forget about test data set. Okay, consider everything, whatever you have. Suppose this is the model data set on which you are going to go ahead and train. So this is my train data set, okay, on which I'm going to train the model. Sorry. So this is my training data. Now, if I have a training data, suppose I'll just keep it simple. Suppose I have 1, 2, 3. Suppose this is up to 100. Okay. Now, what we go ahead and do in the first we train the model. Okay, so when we train the model, we only get one model when we go ahead and do this, right? So we only get one model, right? In the validation, what we try to go ahead and do, okay, in the validation, we try to keep on, just to keep it simple, if I have huge amount of data, right? Okay, so what we try to go ahead and do, we alter, okay, basically suppose this is training, or let me just put it as, yeah, training is fine. So what we try to go ahead and do, suppose I'm just giving example, suppose 1, 2, 3, 4, 5. I'm just giving example. This less data set will not do. So I'll create one model, okay, by making use of only 5 data set point. Okay, only five relevant information, or you can say 5 data points. I'm again telling 5 is just an example. So if I do it this way, okay, if I do it this way, I should be able to go ahead and create 20 models, right? Suppose, okay. So when we go ahead and do 20 models, okay, basically you can go ahead and say, okay, you can take an average of all this. Suppose when the first model was being trained, okay, it had an accuracy of suppose 90. The second model had an accuracy of maybe 80. The third time the model was trained, it was having an accuracy of 95 and so on. After going ahead and taking all those accuracy and taking an average of it, okay, taking an average of it, it will suppose I got an accuracy of 91. So this is more of a cumulative thing. So what we are trying to go ahead and do, rather than you can say taking a single data set, we can go ahead and train it over multiple data set and finally go ahead and you can say make use of that thing as an average thing for the model selection. Okay, one thing. Apart from that, one more thing that we can go ahead and do is, first thing is I told we can split or we can randomly select different set of train and test data set. Okay, we can randomly select different. I'll just put it this way. So suppose I have total data set. I'll just put it this way. Total data set points as, this will be far better, as suppose 1 million rows. Okay. Now if I have 1 million rows, okay, I will go ahead and do a 70-30 split. Okay. Now, rather than just doing a 70-30 split, it's important that we just do not do 70-30 split. We can do this 70-30 split randomly every time. So rather than just creating one model out of this 70-30 split, wouldn't it be better if we can go ahead and randomly do this 70-30 split? Okay. So first, on the 70% trained data set, we are going to train a model. And then on the 30% data set, we are like test data set, we are going to test the model. So we will get one model. And suppose this model had an accuracy of, let us just say 80%. Okay. Example. So this was just one. What is validation? In the validation, this is a term that I am using. Again, it varies from system to system. But again, the overall theme is this only, that we go ahead and create 70-30, okay, randomly, okay, multiple times, okay, multiple times, okay. So when we go ahead and create this 70-30 randomly multiple times, it can be that whatever was there in the test can come into train, whatever was there in the train can come into test, right? So when we, or you can say 60-40 if you want it for the safety bet, okay, so that you get more randomized sample. So suppose by doing this, I was able to go ahead and check out 5 models, okay. I created 5 models using the same machine learning algorithm. Okay. We randomly go ahead and select a sample of 70-30. And suppose I create 5 models. One is having an accuracy of 80. Suppose second got an accuracy of 90. And we are following all the laws of machine learning. Okay. When we are trying to go ahead and do that. One got an accuracy of 95 and so on. And when we took an average of this by dividing it by 5, suppose I got an accuracy of 88. Okay. This model, like you can say, when we were able to get an accuracy of 88, okay, just to give an example, okay, so, or you can say out of this all, this is the average accuracy, or suppose we got an accuracy of 95, so we can put this into production, okay, or before production we can put this onto staging. Okay. And don't consider this, just forget this. What I'm saying, you have got 5, right? So you put this also into staging. Suppose in staging, I'm going to give this to K21 people to use it. Okay. I will also put this to staging. Okay. Staging environment means pre-production environment. Okay. I will put this also into staging. Okay. And then when I put into staging, this will be on the live data set, right? On a sample of people. Okay. And based on the performance that I was able to go ahead and get, I can decide which was the best model to be able to go ahead and put it into live environment. Is it okay now? Now, this is one thing. And basically, this is what we call one more thing that I would like to highlight. See, we are going to cover all this, but it's good to cover it right away. Okay. And do remember all these things because this will help. There is also something I'll just tell you. Every algorithm that you select, okay, suppose as I'll just give an example. Suppose I select an algorithm, suppose called as algorithm 1. Okay. Every algorithm that you select has got some parameters. Okay. Do you remember this? Those parameters are called as, if you tune those parameters, that means you can alter those parameters. You can alter the parameters. Okay. And when you alter the parameter, it is more like a setting. Okay. Like how you have a setting in your TV. Okay. If you change it, automatically the sound that you're going to produce can be different, right? There are different types of sound, like ambience are there, right? Which we can control. Similar to that, I'm trying to help you understand. Every algorithms have parameters. If you alter the parameters, suppose I'll just give you an example. Suppose I was using two parameters, P1 and P2. Okay. P1 can take a value. I'm just giving an example. P1 can take a value between 1 to 10. And the default value, okay? The default value was 5. Okay. Default value is 5. Please forgive me for the spelling mistake. And it can take any value from 1 to 10 in step of 1. I'm just giving an example. Okay. Now, similarly, I had one more parameter. Okay. There are so many ample of parameters are there. It can take a value of suppose, I'll just say suppose 1 to 1000, or just say 100 to 1000. And this can take a value in step of 5. Okay. Multiplication of 5. Okay. I'll just put it this way. So here, and default value, suppose it is 500. Okay. So if it is 500, suppose it can take three value, 100, 1000 and 500. Okay. Sorry. First value, suppose it to be 0. Okay. Just helping you understand. And the default value is how much? Default value is 500. Now the point is, please forgive me for this. Keep it 0. Is it okay now? Step of 500, sorry, step of 500, I told 5 times of this. Is it okay now? Step of 500, like we will keep on increasing by 500. Is it okay now? So suppose the default value was 500. Okay. And we can take 0, 1000, 500. Is it okay now? I'm just giving an example. So the default value was 5 and the default value was 500. So when you kept the default value, now if I ask you how many combinations are possible, think about it. It can take 10 values, right? Yes or no? First one. Second can take how many values? 0, 500 and 1000. So how many? 3. So actually 30 models can be created just by making use of one algorithm. Okay. 30 combinations are possible. I hope everyone is okay. When you alter this parameter, then you go ahead and call this type of model as hyperparameter tuning. What do you call it as? Hyperparameter tuning. Is it okay? So you tune the parameter, and these parameters are called as hyperparameter. Okay, which can be tuned. Okay, fine. So this is also one of the way to go ahead and validate the model without changing the data. Here I am not changing the data also, right? If you remember randomly selecting the data, also, if I don't do, still I'll able to go ahead and create multiple models, right? By making use of a single algorithm. Is it okay, guys, what I'm saying? And then you can select the best one. That's fine. Everyone okay? First one was varying the data set, right? Second was varying the parameter of the algorithm. All okay? Now let me just take it ahead. I just run this. I'm creating a copy. This is the copy. Now apart from that, what I'm trying to do here, you can see, I'll just help you. This column means all rows. This also means all rows. So right now, this is my data. Okay, what I'm saying, I'm just helping you understand. I'm saying X will be equal to everything apart from the last one. This means all columns apart from the last one. So X, what we are saying is X will be equal to everything apart from the last one. This is X. And Y will be equal to, just see, only the last one. We are passing the list of last one only. So Y will be equal to this. So what are we first trying to go ahead and do? We need to understand. First, we are splitting X and Y. This is target. Sorry, this is input and this is output. First, we need to do input and output. Okay. y minus 1 is written. You can automatically understand. I have just written it. Okay. So we are able to go ahead and get this information. Okay, I'll run this. Now, once this is done, if I show you the x head, you can see the x head. If I show you the y head, you can see the y head. Okay. So this is the value of x. Here you can see, and this is y. We need to go ahead and split the x and y. This is not splitting the data right now. This is basically splitting the data into input and output separately. Okay. Now, once this is done, this I have already shown. If you can see, this is the thing that I have gone ahead and shown. Now, this is what you go ahead and say is splitting the data into input and output. Once this is done, again, sklearn has pre-processing, sklearn has so many things. If I show you, sklearn has something called as pre-processing. sklearn has also got other things that you're going to look once we go ahead. So right now we saw pre-processing. Then in sklearn, we have also got something called as model selection. Under this, we have something called as train test split. Now, what are we trying to go ahead and do? I'll just show you. We are creating 4 variables. I'll just show you. What are we saying? I want to split the data, which is there in X and Y. How do you pass? First, you pass the X data set split. What are we saying? X should be split into two, X train and X test. Always remember X train and X test first will complete. Then Y will be split into two. Okay, Y train and just look into what is there on the left side. Y will be split into two. What it will be split into Y? Y train and Y test. Then we are saying test size will be equal to 30%. You can even write train size is equal to whatever you want to put. Okay, always see that test size is less as compared to train size. Then we can set a random state. What do you mean by random state? I'll help you understand. If I want to reproduce the same, see, if you remember, the moment we go ahead and do this over and over again, every time new type of random X and Y will get created. See, this is X train. Okay. This is X test. I have split now. Okay. This was whole X. And now similarly, against X, we will have Y train. Is it okay? This will be Y train. And against Y, we will also have, think about this, Y test. Okay. So we will have X train, X test, Y train, Y test. Now, every time you go ahead and do, it will automatically jumble up the thing. So if you want to reproduce the same state over and over again, you can set the random state. You can put any value, but see to it that you reproduce it. So when you set this value, automatically every time it will have same chunk split, same chunk of split. Chunk will not get distorted anytime. Okay. The same chunk will get reproduced every time. Okay. So if you want to have reproducibility, maybe you are going to run it. Okay. So you can have a random state in your system. So total data set is how much? 15. So 0.7, 70% of 15, I have set 70, 30, right? So it will be 10.5, it will be 11, and 30% of 15 will be 4.5. It will be considered as 4. Okay, now if I scroll down, just see what do we have. Just look into this column. See this 2, 10, 7, 1, 9, 8, 7, 4, 5. Okay, this is X train. Now I want you to look into Y train. Can you see the same numbers are getting repeated here? Okay, same thing. Guys, I hope that's okay. Now, even if I run it again, do remember 2, 10, 7, 1, 9. If I run this again, same thing you will see. Can you see? Same thing is popping up. Why? Because the index is same. If I change this index, let me just change it to 1, 2, 3. If I run, just see what is happening. 2, 7, 10, 7. Now see. Guys, can you see the change? Same thing you will automatically, that same thing will get reflected. Everyone is okay with what I'm saying? Similarly, if you see X test, again, you will have similar kind of thing popping up in X test. This is it about the pandas that I wanted to teach you with respect to machine learning. Any questions so far with respect to pandas? Do let me know. Okay, one more thing. Let me just say. Let's just add it. I'm just converting it into this markdown so that we can directly use it. So NumPy basically stands for numerical Python. Okay. efficient and very fast computations we can do with NumPy. So basically, this is a library for Python for doing numerical computing. It stores the data basically in the form of array. Okay. This is what in other languages we also call it as matrices, but we store it in the form of arrays, wherein you have single dimension, multi-dimension arrays available. Okay. So just to keep it simple, if you see an image, you all have seen an image. Now we do know images are made up of how many colors? R, G. So any image, suppose this is the image, will automatically be having you can say three colors. Okay. So if I try to split all the red color, wherever there is a red color, I'll put it here. Then I can have one more image, right? Okay. And then I can have one more image. So if I try to divide them into different colors, so I can say that this one image is actually constituting of this three image, right? Okay. So if I have 10 images, then you can understand what is going to be the total number of, you can say, informations that you'll be able to achieve, right? So for 10 image, just consider 10 into 3, it will be too much, right? I hope that makes sense. So basically, when you want to go ahead and store this many data point, and you do know that every color will range from which value 0 to every pixel point will have a value between 0 to 255, right? I hope that makes sense. Okay. So if you want to store huge number, okay, now there are so many pixels available, and every pixel can have any value between 0 to 255, and there are n number of pixels. Just to give you an example, if I say 10, now you have cameras, right? Where when you click a photo, you do see that you have 10 megapixel. Have you seen this kind of a thing? Now mega means what? 10 raised to 6, right? Is it okay? So 10 into 10 raised to 6 will be how much? 10 raised to 7. Now this is, I am saying one dimension, okay? This many pixels are there. So if I ask to look into one image, you can consider this to be an image which is having how many pixels? 10 raised to 7 pixels are embedded in this one image. Okay. One image I am saying. Okay. Now, if it is for one color, I am saying, right? So for three color, it will be how much? 3 into 10 raised to 7. And if I consider it to be 10 images are there in my system, so you can consider it to be 3 into 10 raised to 8 pixels. Okay. So the point is, if you want to store so much amount of data, which is multi-dimensional, okay, then you need a way to go ahead and store and do computation on that data, right? Okay, and for that you do require NumPy. Okay, so these are basically called as n-dimensional array. Okay, you can do calculations. You can even do high-end Fourier transforms. If you want to generate random numbers, okay, like every image is a random number, right? So initially, every image that is being, suppose there is an image, if you want to go ahead and take any image, basically it will be a set of numbers, right? And those are randomly generated. Okay. So if you want to generate some random number and compare it against an image, whether it is an image or not, again, you can make use of numbers. Okay. Now, random numbers are basically used when we go ahead and make use of GAN network. GAN is Generative Adversarial Network. Again, NumPy is generally used where we go ahead and try to create computer vision systems. Okay. Or just to keep it simple, we can also use for text analytics, okay, to store huge amount of feature. So if you remember, I did inform you, if I have sentence, the cat sat on the mat, the cat meows. So if I ask you how many unique words are there, the cat sat on the mat. 6, right? And the cat meows. How many unique words are there when you combine all this two sentence? Tell me. 7, right? So if there are 7 words, you need to go ahead and store it in numbers. So just for 2 sentences, you are able to have so many numbers. So consider a book of 1 million pages, or suppose 1 million words, sorry, not 1 million pages. Consider a book wherein you have lots and lots of words. So you can understand that how many numbers, if these words are unique, how many numbers will be required to store them, right? So generally, whenever you want to go ahead and work with text, whenever you want to work with images, where you want to go ahead and store the things in the form of numbers, so that machine learning algorithms can go ahead and build on top of it, so that we can create predictive analytics. NumPy is really an efficient system. Okay. So if you want to do some imputation, you can do. Okay. Apart from that, if you want to broadcast, when we say broadcast, suppose I want to go ahead and perform matrix calculation. I hope everyone has performed matrix, right? So whenever we want to go ahead and do matrix calculation, suppose if I want to merge two things, add two things, scale two things, that process is called as broadcasting. Okay. So if I want to do some matrix calculation, I'm saying matrix operation. Okay. I can make use of broadcasting. Suppose I want to multiply two matrix, I can make use of broadcasting technique. Okay. Similarly, if I want to integrate it, like if I want to use NumPy with Pandas or Scikit-learn, very easily possible that we can go ahead and use it. So why do we use NumPy? I told you to go ahead and pre-process images, okay, or to go ahead and pre-process text data. We do make use of NumPy because apart from that, whatever we have, okay, like simple thing, if you remember Excel data that I have, okay, wherein I can go ahead and make use of the systems that we understood, right? What was that system? To convert one hot encoder, label encoder was good enough, right? But if you want to deal with huge number of data points, wherein you have large number of features also, like huge number of features, okay, not in the capacity of an Excel sheet, I'm saying in the capacity of text data or image data, then you need to make use of NumPy. Okay, now what are we going to cover in this? We will understand importance of NumPy. We will understand how to create arrays, how to search from the array, how to slice an array, what are the mathematical operation. Okay, broadcasting also we will see, basically matrix multiplication aspects we will see, and how to work with multidimensional. So we will look into this. One more thing I have added is how can we use NumPy for text analytics? Okay, we will look into this also. Like if we have a raw text, what is the first thing that we are going to do in the raw text? Okay, if we have a raw text, we are going to tokenize it. Then we are going to go ahead and make use of TF-IDF. We will look into this. This it basically converts this text into something called as numbers, which can be processed and checked for similarity with the help of NumPy. We will look into that aspect. Okay. So if I want to check whether two texts are similar or not, we will look into one use case also. Okay, NumPy text analytics. Okay, so we'll look into this next time onwards. Okay, and apart from that, we will also go ahead with, well, yeah, we will go ahead with direct hands-on for supervised machine learning. I have kept all these things, whichever is required, and I'll show you.
Now you know NumPy is great for crunching numbers fast, and Pandas is your best friend when working with labeled tabular data. So knowing when and how to use these libraries can take your data skills to the next level and save you hours of trial and error. Also, make sure to check out our upcoming AI and machine learning free masterclass and grab the opportunity. Thanks for watching, and make sure you find our previous Python series videos over here.